let's jump to the dictionaries and see what is the dictionaries in Python. Actually, I want to talk about, let's get rid of this guy in here. Yeah, I want to talk about something. In the linear search, it is common to test whether an element is present in a list or not. You remember we have had lots of examples and tasks that I have asked you. If there is, for example, a digit in a list, in a string, or if there is, I don't know, maybe acronym, or if there is anything, any character or something like that. So it is common to test whether an element is present in a list or not. It could be a list or it could be in a string. Okay. One approach is to use the linear search. You remember the linear search. Linear search was the way actually you started from the beginning of the string. You used to test the things one by one. As soon as you get the thing you are looking for, and then you will extract that part as the result of the search. That was the whole concept of the linear search. For example, given a list A and the value V, we can test whether V is present in A as follows. Okay, so we used to set a counter, which is the beginning of the string we have, and then we will continue searching until we scan the whole string, and also we have not found anything. So you take from the first element, is I less than length of A? Yes, because the length of length of a string A, if it is not empty, so it is not 0. So I 0 is less than something else than 0. Okay, and is that a specific element and position I equal to the thing I'm looking for? No. Okay, I will increase the index. I will back. I'll continue until I get to the end of the string A, or until I have found the first appearance of character V I'm looking for. So as soon as I find that, I will cut the while loop, and then I will say if I have not finished the whole string, I'm somewhere here, so I will say V is present in A, and otherwise I would say if V is not present in A. Why I'm doing like that? Because I'm checking both condition in one sentence in here, in one command line in here. So then I need to check if I'm in here. So that was the whole strategy of linear search we talked about. Let me check to see if we have any chat or not. I'll keep the chat box in here for me to make sure I won't lose any comment or questions. So it might happen a lot in the codes actually we write. So sometimes we want to do this process quite a few times. So like I've mentioned that in the previous weeks, why not to define a function? So for example, let's define a function which is in, for example, which takes two arguments, A and V. A would be the list or string with which we are working on, and V is the character or a string that we are looking for. So then I will implement exactly what I have had in here into this function, and then I will return it in here. I will return it in here. So in this case, I don't return the index of the position of the guy. I return true or false. Why? Because it returns what is the result of evaluation of this guy. If I is the less than length of A, the string or the list we have, true or false, and then I will return that. So that's a function I have defined. I could return I if that suits you the best. So you need to look at the problem you have in your hand and see which way works the best for you. So in this case, probably I'm interested in returning if I have V happened in the string or list of A or not. That's the case. So now, whenever we need to test whether, see, I'm not testing the position. Whenever we need to test whether an element is present in a list, we can just use the function. So that's the function I've developed. Like I said, if you are looking for the position, you can return the position I instead of conditional checking like this. Okay, and if that's the case, you need to add these elements, of course, inside the function if you are looking for the position. Okay, right. So now that we have defined the function, let's look at an example. The task could be write a Python script which copies a standard input to standard output, removing duplicate lines including non-adjacent duplicates. Okay, so we want to copy whatever we have in the input to the output, only the unique one. We don't want to print the duplicate ones. Okay, so let's start the file, whatever is the name of the file, like that. I want to import sys because I want to use something like std in, std out, blah blah, etc. So I need to import sys. So I have the same definition of the function we talked about above. So is in A and V, blah blah, etc. And then that's, like I said, the true or false. So then I read whatever lines, read lines. You remember that's read lines. I read whatever lines I have inside the input argument or the text file, everything, and then that's the kind of an empty list that I want to push all the unique stuff inside that. Why I want to do that? Because I want to be able to check if I have had already that inside scene or not, if I have seen already that string or that specific character or not. Okay, so then I would say while I is less than lines, what does it mean? That means I want to check all the lines I have read from the input. Then if not is in scene and list I, what does it mean? That means if the first line is available inside the scene, which is empty, that will return us true or false, right? But I want to make it opposite, make it negative. I mean, it means if it is not, if the function say is in, that means if it is not in. Okay, if not, something like that, that means if it is not inside that, please print that specific lines in the output, and also please append that specific line into the scene. That means when the first time I go inside this loop, what would happen? Scene is empty. I read the first line. Is it inside the scene? No, it's not. So it is false. That means not will change it to true. Okay, that would be I will go inside the if kind of loop, and then that means I will print that, and that means I will add that specific line into the scene, and then I will exit the if, and then I will increase the I will go for the second line. For the second line, I check if that second line is available inside the scene. If it is yes, that means it has happened. So that means it is no or false. So that means I will skip the if and I will increase the I. Or if it is not inside that, the answer for this function is false. That means this not makes it true. I will go inside that, I will print the next line and will add that specific line into the scene. I increase I and go on. So that's the whole story of this guy. As you can see, using this specific function, I have made the life much easier. As you can see, I have made the line much easier. Instead of adding all these lines in here inside the guy, for example, define a specific value first of all, calculate these things, and then check if that specific variable is not true or false, something like that, and go inside that. So that's much easier. So that's a good example of how defining a function is interesting for us. And the need only you need to make sure is the function should be defined before its usage. If you define the function after the usage, probably you will get a syntax error, you will get an error in Python which says function has not been defined. So you need to define the function in here. So that's the point. And also the other thing we are seeing for the first time is the write function of stdout inside the sys module. So that guy prints the things for you in the output. That's a good idea to get familiar with that. And like I said, you can just search this thing in Google if you want to understand how to use it, and if you want to get more insight and more information about that guy. So somehow we have implemented the in concept. Somehow we have implemented the in concept. If something is inside a specific list or string, something like that. Well, probably Python, definitely Python has thought of that. What does it mean? It means in Python we have a built-in operator for testing the presence of a value in a list, which is called in operator, right? So the example above can be rewritten without the need for user-defined function as below. So you don't need to define the function yourself. So that means you import sys because you want to use the writing here in stdout, and then you read the whole lines in line, and then sin is empty, the counter is 0. You will go through the lines, and then just easily you say if that specific line is inside sin. Interesting. So that means Inoperator checks the thing you want inside the thing you want again. Okay, so the result would be if what is the answer for this guy? What's the output for this guy? If line I is inside in, if it is inside, it is true. Then it is false. That means I don't need to go through the if block of code in here, and then I can increment I, and then back to the top. So that's the same implementation, but as you can see, in terms of the line of code, not that many differences. We have the same line of code apart from can you explain? If not, yeah, I will explain it again. So in terms of the line of code, it is the same apart from the definition of the function, user-defined function you had in here, but you don't have it here. So that's one difference in here we are facing with. And the second difference, we will discuss that. What's the second difference? Well, question is, what does it mean, the not? I will describe that. See, I have some lines read from the input, right? And sin is empty. Counter is 0. I want to check all the lines in here. I jump in here. That's the first time I is 0. 0 is the length of the things. Yes, okay. Is the first line I have read from the input inside the scene? The answer would be true or false. Since the scene is empty, that means the first line is not inside there. So what would be the answer of this? What would be the return of this operation in here? In the chat room for me, please. I'm in the first round. Scene is empty. I is 0. I am reading the first line, which is 0. It is false because scene is empty. Correct. The scene is empty. There is nothing in there. Is something I'm looking for is inside scene? No. So it is not. So it is false. And not make it negative. Not of false is true. So the whole answer of this part is true. If true, yes, I will jump inside there. I will print that specific part. I will put it inside the scene. I will increment the I will back to the top. See, this guy in terms of indentation, it is exactly aligned underneath of the while. So that means while is not finished. I will back to the top. Okay, happy you understand the situation. So the explanation would be something like that, although we have some sort of the explanation in here too, but I have gone through the whole story myself, as you can see. So the almost correct way to write our example is Python is as follows. Okay, so it says instead of saying not something in, so we can say v in something. That means if v is available in a, not v in, that means if v is available, and then make it not, make it negative. So why not to say v not in? Thankfully Python has provided that opportunity for us. So you don't need to say not v in, you don't need to make it negative. What happens in here, since Python is a high-level language of programming. What does it mean in terms of high level? It means it is more closer to human language than to the machine. If you go toward the C, C++, etc., or assembly, even, it is more closer to the machine language. So it is lower level programming language. But the Python is a higher level programming language. What does it mean? It means it is much closer to the human being writing language. So it is not the way we talk in the normal human language, right? What it is, we not in. Probably in English we will add some verbs or something like that to make it more complete, but in general in Python it is more closer to the human being. So thankfully Python has something like that. You can say we not in. So let's change it. So instead of saying if not line I in scene, we can say if v line I not in scene. That's much easier. That's much easier to understand, to write, and so on. So we have two options in here. We have, in terms of the in operation, we have the option something in something, and we have the option something not in something. See, that's very similar to the writing to the English language or other languages. You say something not in blah blah etc. There are some probably minor differences between Python 2 and 3 etc. So you'll get used to it. You know where to use in Python 2 or how to use it in Python 3. Okay, so that's the thing. So what was the differences I talked about? I said in the linear search, first of all, if you want to define the function yourself, the first thing you need to add is the definition of the function. That was one extra stuff you needed to add. And also the second difference was it was not that much close to the human being language. There were two main differences in here. But what is the third difference and the most important difference? That's the cost. How much computation power and time it takes from the machine to implement both of them. So linear search, in terms of the operation, in terms of the complexity, it is called the complexity. This is a way we show the complexity of an operation of order n. It shows the complexity. So therefore, the worst and the average case complexity of the linear search based solution to the problem above is n2. Are you familiar with the complexity? Can you please answer in the chat room if you have read that in your course stuffs, etc. So you are not familiar. Okay, I will go through that shortly to see what is the concept of the complexity, time complexity. So as you can see in here, we are a very good explanation in this website, Geeks for Geeks. So I will go through some of the interesting things in here. So look at these things. That's obviously in C language, but it's not important. It doesn't matter for us now. We want to focus on something different. So that's the simplest code ever when you want to start learning a programming language you work with. That's the hello world, right? So what is the order of complexity? In the above code, we have only one print. Okay, so time complexity is constant O1. What does it mean? It means this guy is executed only once. So the order of complexity is constant and it is 1, right? So what about this guy? Let's look at this guy. In this guy, I have a for loop and I will do that specific operation, not just once, but n time, right? N is 8. I will print n until I is less than or equal to n. So I will print it 8 times, and that will be the output. So in the above code, we will print n times. So time complexity of above code is O(n). So in this case, I would say the complexity of this code is O(n). That means that's linear and it is repeated n time. Why? Because I have n time of operation. In this specific guy, n is 8. You could say O of 8. Well, you don't need to do that. O(n) is enough. That means it is linear, the number of operations you do. Okay? Well, let's look at this guy. Let's look at this guy. So that's a sum function. That's a pseudocode anyway. That's not the real code you can implement. You can do it you can execute it in any language. That's a pseudocode. I'm trying to implement how I'm going to solve something. Okay? So sum of a, b is a function. It takes 2 units of time, one for arithmetic operation and one for return. So what does it do? One operation is doing the summation and one operation is the return. So what is the complexity? So the complexity is 2. It is a constant, and O1 is the time cost. Okay. So what about this one? Let's look at that. So the time of this summation takes, I'm trying to sum whatever I have inside the list, and the total is 0. I have a for loop in here, n time, and I'm doing some operation inside that. I'm doing the sum. So what I need to see what is the time complexity of this guy, and I have a return. Let's review the things. This operation is constant. Once I set 0 to total. So the number of time I implement that is 1. Then inside this for loop, the cost is 2, okay? And the number of time I'm repeating that is n plus 1. Why n plus 1? Because I repeat the loop n time, and the last time I check this for guy, and I see I'm finished the criteria, I should exit. So I'm repeating that n plus 1, okay? And then in this sum, I have the cost is 2 because I'm doing the summation, very similar to this guy. Okay? I'm doing the cost is 2. Why? Because one is the sum, the other one is taking something from the list I have. And how many times I repeat that? I repeat that n time. And for the return, the cost is 1 operation. And how many times I repeat that? I repeat that once. Why? Because as soon as the for loop is finished, I will return the sum and I will exit the function. So let's calculate the operation. So I have operation cost of 1 time, plus I have the cost of 2 n plus 1 time, I have the cost of 2 again n time, and I have the cost of 1 time. So it would be 1 plus 2 times n plus 1, 2 times n plus 1, 4n plus 4, and it would be kind of, if you get 4 out of this guy, would be 4 times n plus 1. N plus 1 is equal to n. That means c times n. Okay, so that's linear again. As you can see, the time complexity of this guy depends on n, which is linear. It doesn't depend, it won't depend on n square or something like that. Okay, so the time complexity of this guy is n, order of n, linear. And let's say we want to do summation of all elements of a matrix, right? In the matrix we have 2 dimensions, so you see we will have 2 for loop inside each other. So that's the reason why the complexity of the guy is O n square. Okay, it is more complex, and that's obvious. Yeah, summing the things inside the list, one-dimensional list, takes less time and power than summing the things inside a 2-dimensional data. It is completely obvious. So you will have that in your courses, stuff, etc. Just I wanted to have a very quick and short explanation of the time complexity in here for you. Like I said, you can search it in the Google yourself and you can find a lot of good pages and you can go through that yourself. Okay, right, so let's back to the things. So the linear search time complexity is ny, because inside the list you have n element, inside your string you have n element, and you will go through the elements one by one, and how many times you repeat that, n time. Okay, and then you need to do some other stuff, so the time complexity altogether would be n2. So therefore the worst and average case complexity of linear search based solution to the problem above is ON2. Using Inoperator does not change that. Testing for the presence of element in a list is fundamentally ON, so the cost of using the N operation in, so the in guy for itself takes ON, and also you repeat that N time inside the loop, so again the time complexity ON. So in terms of the cost, as you see, it remains order of n2. It doesn't change the complexity that much. If you want to use the in built-in operator, or if you want to do linear search yourself. So that was in terms of the cost. So one way to think of a list is the mapping from the integers to the values. Okay, so let's recap by far. By far, we got familiar with the operator, built-in operator in, which is very interesting in terms of implementation. In terms of lots of things, it was more interesting than the linear search. But in terms of the complexity, time complexity, it was the same. So we want to go through another element which is called dictionaries, which is very interesting. So let's have an introduction in here. One way to think of a list is a mapping from integer to values. Looking up the values associated with a particular integer is fast. It is O1. The cost does not depend upon the length of the list. However, testing for the presence of the value in the list is slow. We potentially have to examine every element in the list. So that's the most important thing we are looking for in this introduction in here. So when we want to check something inside the list, we need to check everything one by one ourselves, and that takes a lot of time and energy from us. That order of n comes from checking the thing inside the list, even it is in operator, or even it is the built-in, which is the user-defined function you have written yourself. Okay, so that's the problem of list. If you want to find something inside the list, you need to check everything yourself. So what's the solution? The solution is a new element which is called dictionaries. So a list is the mapping from integers to values. What does it mean really? Do you get what does it mean? A list is as a mapping from integers to values. Can you write for me in the chat box if you have any idea what this sentence means? This sentence is for me, it looks a little bit vague. So do you understand it? In the chat box probably. What does it mean? So a list so you have a list, the element 0 and then element 1, element 2, 3, 4, 5. What does this mean? It has two things as a pair, okay? And what are those two things? Index matches it, exactly. Indexes matches values. What does it mean? Index means the position. Position 0 matches the value of position 0. So that's kind of a mapping we have had already in the list. So the answer to that is what you can see in here. So indexes matches the value. Yeah. So that's the whole thing. A dictionary is a mapping tool, but in this case it is different from a values of any immutable type to the other values. For a purpose, the keys will most frequently be a string. So let's go through this example, it is much easier. So the difference between the dictionary and the list is in the list you have just the position, and in the position you have the values. You have a list of, let's say, for example, some integers 1, 10, -2, blah blah, etc. What is inside position 0 is 1. What is inside position 1, position 2, and so on. But in dictionaries, first of all, you show that using the curly braces, not the bracket. And the second thing, you have the keys. You have the key and a value for key. That's the first element of the dictionary. That's the second element of the dictionary. That's the key and that's the value. That's the key. These are the keys and these are the values. But they should be the same type. I mean, if you are going to have a string of probably name or something like that, and then probably the birthday, it should be okay any number inside that, but the whole story should be the same. It couldn't be the different type of the things inside the dictionary. So in dictionary you have the same type of the thing, very similar to the list, but the difference is you will have the keys, and using the keys you can say what you will have in here. So if I want to print the date of birth of this guy, for example, I can say print of dictionary people this key. What is the value of this key? It will print for me this guy. See? An interesting thing is in here. When I want to have access, I'll use the brackets. But when I want to define the dictionaries, I will use the curly braces. So that's all. That's the one difference. We'll see what is the whole thing. What is the other advantage? So each entry is a pair, right? A key and a value. That's a pair, key and a value, and they are separated by a column, right? And then you will finish it within the comma in here. In the example above, the keys are people's name and the value are the date of birth. The key and the values are both strings. We can assign values to the keys. That's the very interesting thing. You can start an empty dictionary in here, and you can say inside that dictionary for this key please put this value. That means please add this key to this dictionary and the value, the corresponding value, so I can fill the dictionary myself from the data I have. That would be very interesting. We could do that inside the list too. We could append something to the list in different ways, or we can append also the things into the dictionary in this way. Okay, then I can print it. For assignment and lookup value, we use square brackets, just like with the list. I have described that already. Okay, the in operator, the interesting part. Let's see how in operator works inside the dictionaries. We can also use in operator with dictionaries. In this case, the in operator tests whether a key is defined in dictionary or not. So I would say is Justin Bieber in people? So that means this guy will go to the dictionary people and then we'll check all the keys to see if that is specific key inside the guy, and it doesn't return for us the value because we are not looking for the value. We are looking for only checking to see if it is available or not. So the answer would be true. If this guy John Lennon in the people, no, it is false. If it is this guy not in, see, interestingly we can use not in again. So that would be one interesting thing. You could do that in the list too, kind of, okay? So what about in terms of the cost? That's one of the most advantages of the dictionaries over the list. The cost of operation is 1. It is not n, cost of searching inside the list. Cost of the searching inside the list was n. Why? Because we needed to check n time all the values, all the entries inside the list. But in dictionaries, we don't need to do the search inside all of them. And dictionary, just go through the dictionary once and pick the value for us, if it is inside or if it is not. There's a question here, can we do print people to print the print? Yes, sure, for sure we can do that. We have had that in here. To print the person's name, no, you cannot have access to the dictionary using the value. You can have access to the dictionary using the keys. The key is the thing you can have access. You can check it. You can write a for loop, for example, or if. You can say go through the list and check the keys one by one, and if the value is equal to the value I'm looking for or not. If it is, do something. Right? So that's a solution for what you're looking for. Maybe naive solution. Maybe, I don't know if it is efficient. You can probably write it more efficiently. But in general, you cannot have access to the dictionary using the values. You can have access to the dictionaries only using the keys. Okay, so in terms of the cost, then it is really good. It doesn't need to go through all the elements of the dictionary to find the thing for you. One go, it will back and say if it is available or not. So with dictionary, we can rewrite the application example. So let's have a look at that. So I have this, I read all the files, all the lines, sorry. Scene is empty, this time it is a dictionary, not a list. Okay, so I is equal to 0, while I will go through all the lines. I will say if that specific line is inside the dictionary, the cost is 1 now, it's not n. So then I will write it, print it. That's the same exactly, but instead of defining a list, I have defined a dictionary. And what's the benefit of that for me? The benefit of that is the less complex. So how it is important? If you write, for example, the code, if you solve the problem using this method, and your colleague, your classmate, solve it using the list method, and if you run it on the computer, both of you will get the result the same, so that's okay. So what is the point of the optimization? When you want, that's a real world example again. I'm really interested in the real world example. In the real world, you want to implement the algorithms into the embedded platforms. In embedded platforms, you are really in shortage of the resources. What are the resources? The power, right? For example, that's a drone. It is flying. It is the power is the battery, and the battery doesn't last forever. And it is so important to take less energy. How it takes more energy? If you do more operations, that means for any operation, your machine needs to consume some energy. Okay, so and that's the point why in the real current world platforms, they try to send the things to the stand-up, lots of operation to the stand-up. In the Intel platform I was working with, we had some operation, some activity detection built-in function and filters that could detect if anything happens in front of the cameras, then send a wake up request, and then the system will wake up. So this way we can save a lot of energy. So in the real world situation, which are the embedded systems, you are in the shortage of the resources, the power, I described that, and the memory. You cannot have as much as memory you want. It's not like your computer, buy whatever memory you want. So you are really in the shortage of these resources. So you need to optimize that. So when you want to implement something in the real world platforms, the embedded system, you need to optimize the things. You need to implement the codes. I remember like 20 years ago when I was working on development mobile switch center, we used to go inside the lines using the ASCII. We used to implement the codes, the protocol using the C language at that time. And we used to go through the lines of the code in ASCII to see how many cycles it takes to be implemented, to optimize it. And sometimes we used to check it, to test it ourselves to make sure it is really efficient in terms of the thing. So that's the reason why we are interested in the complexity, right? So it is much faster to implement it in this way. So that could be a question in the final exam to tell me which one of these guys, which one of these Python segment fragments are more efficient in terms of complexity, etc. So that's important for you to understand the complexity of different things for you. Okay, so iteration. Given an arbitrary list A of length n, we know all the keys of A. They are the integer values from 0 to n1. This allows us to examine every element in a list using a simple loop as follows. Okay. Given an arbitrary dictionary, it tries to say why it is more efficient, and it tries to show you the definition of how you should deal with the dictionary in terms of the loop. For iterating over the keys of the dictionary, we need to use a different kind of a list, a for loop. Okay. So example, look at that. I have a dictionary of people, the previous dictionary I had in here. So for person, I can have a loop and print the name of the people in here. I can say for person inside this loop, please print the person for me. It will print the value of that person for me. That's exactly the thing we discussed with the value, people, date, if you remember. And I said you can go inside the loop and do something yourself you want. Okay, and it tries to print. Do you see anything which grabs your attention in this part? Look at the dictionary and look at the output. Do you see anything in here? I will scroll it in this way. I want to hide the rest of the lecture for you to ask the question. So my question is, look at the dictionary and look at the print. Is there anything which grabs your attention in here for you? Is there anything that grabs your attention? The obvious thing is actually we have printed the keys. We have printed the keys. So it is possible to print the keys. We are printing the keys. That's the first thing. What about anything else which grabs your attention? You think it looks suspicious? Any differences? Very good example. Very good. Exactly. Thank you very much. Not printed in the order. See, you start with the Elvis, Lisa, Robert, Adel. What it is, Lisa. Oh my God, Lisa was the first one. That's the second one. It is the first time in here, first one in here. So that's one of the things which happens inside the dictionaries. In the for loop, the variable name, okay, and then person is suitable choice. Okay, I will back to that, and that's the reason what I say. The ordering is the problem. In the ordering, that's the problem. And the second thing it tries to say, when you want to use a for loop, you can say for I inside people. That's okay to say that. You are completely okay and free to use any words, any name in here. But it tries to tell you it is better to use the name which makes sense because the keys are people. You know that already. They are the people. So let's say the person. So it helps in terms of the readability of your code. That's I have talked about in the previous sessions also, previous weeks. Other people are the people you are going to work with, the other people in the team, and they may need to read your code, they may need to reuse the code, and so on. So you need to write the code in the way they can understand the code. So that helps the readability of your code. So definitely using the name person in here is much better than using the I, for example. For I in people, it works again. Why it's better to use the person? Person definitely is not a keyword using in Python, but that's the name you have used. You can say I don't know, whatever else you want, but that's the point. And like I said, in terms of ordering, it messes up the orders of the dictionary you have. So what you need to do, you can iterate in the orders. You can use the sorted function yourself if you are interested to see the things in the order. So how this can happen? So I have a dictionary of people in here. So instead of saying for person in people, I can say for person in sorted people. That's a method we use to sort the things inside the dictionary. So if I printed exactly the same thing would be printed in here. Okay, so let's look at have a look at an example. So write a Python script which outputs for each word encountered that word and a count of the number of times which it occurred. So I have these things in the input. I want to print how many times I have seen these things in here. So for example, for dog I have 1, 2, 3, 4 times. For cat I have 2 times, and so on. So what could be the output should be like that. I want to print the name of the animal I have in here, the pet I have in here, and then the number of times I have seen that inside the guy. So we can do it in different ways. We can do it using the list. We can do it in different ways. Okay, or probably dictionary would be a good idea. So we need to consider each word for a standard inputting term, right? For that, we can use the same type of the loop that we have used throughout, a while loop. Okay, and we need to maintain a count. We need to maintain a count of the number. Dictionary is interesting for us in here. As soon as we see the dog, we can add dog into the dictionary as the key, and we can set the number of occurrence as 1. Okay, and then I will continue. When I get to cat, I can check if there is cat inside the dictionary. No. If it is not available, please put it into the dictionary and make the number of count the value to 1. And then continue. When I get to the mouse, do I have is there it available into dictionary? No, it's not available. Add it, and so on. So that's the logic behind how to write the code. Okay, so I need to count. So the keys would be the name of the animals in here, and the count would be the number of time it has happened in here. So let's see how the code looks like. So I will import the sys because I want to read from the input, read lines. I have an empty count dictionary in here for me. I will set the counter to 0 to make sure I check all the lines for myself, and then I will say word is the lines strip. Why I do that? Because it may happen some sort of the white space before and after the things I have. I want to get rid of that, and then I will say if word not in counts, if that's the first time I see that specific word from the input. That's another way to say that. Then I would say count of that specific word is 0. Interestingly, when you say that, it does two things at the same time. First of all, it adds that specific key into the count, to the dictionary, and also it sets the value of that specific key to the 0. And then if it doesn't happen, that means that specific word already is available there. Then I can say for that specific key into the dictionary, please change the value to +1. Increment the value. And then increment the counter, go to the next line and repeat that. See, very interesting. Please practice it, how we can implement it using the list, for example. You see, it is a little bit probably more challenging. Probably you need to define 2 lists in parallel. Probably it is a little bit more complicated to know, okay, that a specific location in the second list is corresponding to the first list of the input, and how I should change it, blah blah. You need to have another counter, set the counter for example for dogs, set the counter for, see, different ideas. So it looks a little bit more challenging if you want to use it brute force, let's say, ideas, naive ideas. But dictionary help us to get a little bit more facilities to implement it. So, and then after I have finished that, I would say for word in sorted count, please sort it for me first, and for the word there, please print word, a comma, and the number of time that a specific word happens, the value of that. So beautiful, fashionable implementation of the idea. Like I said, so as much as you go ahead with the things, some of the students, they might say, I'm happy with that, let's implement it with the list, I know how to implement it. Or you will get a better developer, you will get a better programmer if you try to use the capability of the capabilities of the language as you go ahead. So if dictionary does something in a better way for you, why not to use it? So please learn it. That's one thing. Every week, you remember, I have some advices for you in throughout the course. The other advice could be for you. You need to learn the best practices. You will get a better developer if you focus on the best practices. So you may spend some time in your daily time to look at the implemented code. If you search on the Google, you can see some example code, some good implementation of the code, and you can read through the code of the people to see how they have implemented the things, and this way you will get better, you will grow. That's very similar to the for the writers. For the writers, it is very famous that if you want to get a better writer, you need to read more. As much as you read more, you will get a better writer. For the speakers, if you listen to the other speakers more, you will get a better speaker. That's the same for being a programmer, for being a developer. You need to read the code of the other people, particularly the genius people. How they use, how they play with different functionality of the language to write the things more efficiently, more beautifully, and so on. So you need to get better. So that was the advice of today, recommendation of today. Okay. I remember we used to do that when we were students. Okay, so that's what this is. So explanation, we explained that, and then order is on, because in terms of the search, it doesn't take energy of us, and that's the matter of just repeating the loop for n time to do the things. The order of these things would be 1. Okay, and they are the tasks you need to work on. We don't have too many tasks in here, but the tasks you need to work on Monday, next Monday. So imagine we have standard input consists of sequence of words, 1 per line. Write a Python.fruit, which output only those words which are fruits. I have these things: dog, cat, apple, snake, cherry, blah blah, etc. Only select the name of the fruits for me and upload it as the file with this name. That would be the same example, and then print it, and that would be the print. So the tip and the hint to do that is something like that. You can write the things in here, and if it is fruit, you can say true. If it is not fruit, you can say false, so on. What is the next task? The next task is German numbers. If we have the English numbers, we want to write out the German numbers. Okay, I will finish that to back to the things. So you will go through these things and you will work on the examples. Okay, so what is next? The next things I want to go through some example for you here. Can you see my screen? Still my screen? Can you see my screen? Can you see my screen? I'm going into the next another screen. Yeah, very good. I have this problem in Linux, unfortunately. When I switch to another string, it doesn't show the new string. So in Windows, thankfully, it is okay. So let's say, if you remember, that's a question, some of your classmates have asked me. So I decided to review that in here, and I will share the file with you later after the class. So that was the question, if you remember. First acronyms, we wanted to find the first acronym. So that's the code actually one of your classmates has written, and that's the error has happened in here. As you can see, he or she has got some incorrect on test 1. What are the point of this test? The code you are developing is tested against different type of the input and outputs. Okay, so that's the reason why in some of the cases it has failed. I have marked the IP address to keep the privacy. That's the reason for that. So what could be the problem in here? Since we are in the time shortage, let's look at the solution. The solution would be something like that. Let's check the things. So get the input, counter is 0, then it checks if we are inside the string, and if the input number is, if the specific position is a number, increase that, and then the number is empty if I is less than length of s, and so on. So what's the difference in here? It looks like the first loop is the same. We check the same. Why in here, what is the difference? We set j as I, and then we go inside the loop, and then we check what we are doing in here. In here we are trying to say to take, let me see. We say we are inside the string and the guy is not an integer. We will continue, okay, and then we set j to I. We will say j is length than s. Still we are inside the string, and the guy this time is a number, and then I will increase that, and then if length is, we will print it, we will print the thing. So that's the difference. Since we are in time shortage, I will leave it to you to check the answer with the solution yourself. So that would be one case you have faced with the problem. The second case, it has been the first number. So in the first number again, he or she has got some incorrect answer. So that would be the answer for you again. So check it for yourself to see what is the difference between these two codes and where is the problem. So hopefully it will be helpful for you this afternoon exam. And then in terms of the distance, I have received another question from another student of the class. You remember in one of the tasks we had, you need to write this Python code, you need to take the name of the cities and the states, something like that, and we need to calculate the distance between these two cities. It is a little bit mathematical stuff, and you need to import the math package of the Python, right? So how could be the solution? The solution should be something like that. Solution would be something like that. First of all, I import the sys. I read the things in here myself. The first argument, second, third, fourth. So these are the arguments I have in here. Then I would say the header would be the first line of the file I read, and the cities would be the next lines, because I want to know what is happening in the header. I define a function here to calculate the distance between two cities, because this based on the latitude and longitude. Okay, I get the numbers in terms of, I get the arguments of degrees, minutes, and seconds, and then I return it to seconds. So I would say integer of degrees, I will multiply it by 3600, multiplied by 60 the minutes, and the seconds all together. I will change this coordination to the seconds, and then I will go into the lines, cities. I will take the first one, I will get rid of the extra stuffs, and I will split the things, okay? And then I know if the token 8 is C1 and token 9 is S1, I know the token 8 is the city, and I know the token 9 is the, what was that? The first one was city, the second one was the state. I know if the token 8 is C1 and token 9 is S1, then that means I have grabbed the first city. Then latitude would be converting the thing into the seconds. Longitude also would be converting into the second. And also I will take, I will say if C2, token 8 is C2 and token 9 is S2, convert it and then increase it. So I will go through until I find both the first city and the second city. As soon as I have found the first and second cities, I have the latitude, longitude of the first and second cities, and then I will come to here and calculate the distance. In terms of latitude, it would be latitude of the first one minus the second one square. In terms of the longitude, it would be the difference and a square, the square of the difference. And then I need to import the math. You could import math everything in here to make your code more stylish, but you can import it in here too, that's okay. And then I would say, what is the distance? Distance would be calculate the square of summation of these guys, and then sum it up with the 0.5, and then divide it by this guy times by this guy. That's the formulation of the distance, etc. And I will print the distance. So that's so easy. So let's recap it. I will review, I will get the cities and states in here, I will get the header and the cities, and then I will define a function to implement, to change this coordination to the second. Then I will go through the guide and find the first city into the state and the second city into the state. Some people may say do that, may do that in different loops, one loop for finding the first one and second loop for the second one. But that's extra stuff to do. You can't do everything in the same, in the one line, because you may, in the line you are talking about, it may be the first city or the second city. Both, it won't happen at the same time. So while you are checking you can check the both thing at the same time. So that was the whole story. So that's the examples. I will embed that into the website.